Hello children, now let us understand friction. Suppose a man is pushing a heavy object towards the wall. He is applying a horizontal force F on the object, but he is not able to move the object. At this point of time, weight of this object is mg, that is working at its geometrical center. N is the normal reaction applied by the floor on the object. These two vertical forces counter each other. Then what is that force that opposes the tendency of this object to slide? That force is called as friction force. It acts between the contact surfaces of two objects and its direction is tangential to the contact surfaces. It makes action-reaction pair. That means if the ground applies friction force Fs in this direction on the object, then object applies equal and opposite friction force on the ground in this direction. At this point of time, friction force is called as static friction. It is represented by Fs. Suppose F is increased and still object doesn't move, then Fs is increased. If F is increased further and still object doesn't move, that means Fs is increased further. But there is a limit to which Fs is increased. Beyond that, it cannot. That limit is called as limiting friction. It is represented by Fsm. That means maximum static friction. If the value of applied force is more than limiting friction, then this object starts sliding. When the object starts sliding, the friction force is called as kinetic friction. It is represented by Fk. It is experimentally seen that limiting friction varies linearly with normal reaction, and it is given by Fsm is equal to μs into n. μs is coefficient of static friction. N is equal to mg. So Fsm is equal to μs mg. Similarly, Fk is equal to mu k into n or Fk equal to mu k into mg, where mu k is equal to coefficient of kinetic friction. Relation between static friction and limiting friction is Fs is less than or equal to Fsm. Relation between static friction and kinetic friction is Fs is greater than or equal to Fk. Relation between coefficient of static friction and coefficient of kinetic friction is μs is greater than or equal to mu k. This is the graph between applied force F and friction force. Initially, when the object doesn't move, friction force increases linearly. When object starts moving, friction force drops to a certain level and then becomes constant. There are different types of frictions. For example, dry friction, fluid friction, internal friction, rolling friction, etc. In this chapter, we will focus on dry friction, which occurs between the contact surfaces of two solid objects. It is of two types, static friction and kinetic friction. We will study fluid friction in another chapter. Advantages and disadvantages of friction. The biggest advantage is because of the friction, we are able to walk and run. Disadvantage is it causes loss of energy and it causes wear and tear to the contact surfaces of the objects. Now let us see laws of friction. Laws of friction are summarized in 4 points. First point, if the bodies slip over each other, force of friction is given by Fk is equal to mu k into n. We have already seen that when the sliding starts, force of friction is called as kinetic friction. It is given by Fk is equal to mu k into n, where mu k is equal to coefficient of kinetic friction and n is the normal reaction force. Second point, the direction of kinetic friction on a body is opposite to the velocity of this body with respect to the body applying the force of friction. Suppose force F is applied on a block. As a result, it starts moving on this surface towards right with velocity v. Then this surface will apply friction force Fk on this block in the direction opposite to its motion. Third point, if the bodies do not slip over each other, the force of friction is given by Fs is less than or equal to μs into n. The direction and magnitude of static friction is such that the condition of no slipping between the bodies is ensured. Suppose a horizontal force F is applied on a block, but the block does not move. That means friction force on this block by the surface will be applied in such a direction so that it opposes the tendency of this block to slide in the direction of applied force. Fourth point, the frictional force Fk or Fs does not depend on the area of contact as long as the normal force is same. Suppose there are two identical bricks. They are kept on a surface, first like this and second one like this. In first case, area of contact between the two objects is more, and in second case, area of contact between the two objects is less. But Fs or Fk in both the cases will be same, as Fs is less than or equal to mu s into n and Fk is equal to mu k into n. So they depend on n, and we know that n is equal to mg. So Fs or Fk will depend on mass of these objects. Since these bricks are identical, so their mass will be same. So Fs or Fk will be same in both the cases. Coefficient of static friction μs depends on the material of the objects and the roughness of two surfaces in contact. Now let us see angle of friction and angle of repose. Angle of friction lambda is the angle between vector r and vector n. Vector r is vector sum of normal reaction and limiting friction. Limiting friction is represented by Fsm, and Fsm is equal to mu s into n, where mu s is coefficient of static friction and n is normal reaction. In this right angle triangle, tan lambda is equal to Fsm upon n. Fsm is equal to mu s into n. So tan lambda is equal to mu s into n upon n, or tan lambda is equal to mu s, or lambda is equal to tan inverse mu s. So angle of friction depends only on the coefficient of static friction. Angle of repose. Suppose an object is kept on an inclined plane whose angle of inclination is slowly increased. At certain angle theta, this object will start sliding down the plane due to its own weight. That angle of inclination of the plane is called as angle of repose. From this figure, it is clear that angle of repose theta is equal to angle of friction lambda. Now let us see some questions based on friction. First question, a block of mass 2.5 kg is kept on a rough horizontal surface. It is found that the block does not slide if a horizontal force less than 15 Newton is applied to it. Also, it is found that it takes 5 seconds to slide through the first 10 meter if a horizontal force of 15 Newton is applied and the block is gently pushed to start the motion. Taking g is equal to 10 meter per second square, calculate the coefficients of static and kinetic friction between the block and the surface. This block is kept on a rough surface. Its weight works vertically downwards at its geometrical center. N is the normal reaction by the surface on this block. This block is pulled by a horizontal force F. It is given that when F is less than 15 Newton, this block doesn't move. When F is equal to 15 Newton, this block starts sliding. That means 15 Newton is limiting friction. We represent it by Fsm, that is maximum static friction. So Fsm is equal to 15 Newton. Formula for Fsm is equal to mu s into n, where mu s is coefficient of static friction, n is normal reaction, n is equal to mg. So Fsm is equal to mu s mg, or mu s is equal to Fsm upon mg. Fsm is 15 Newton, m is given as 2.5 kg, g we can take as 10 meter per second square. So mu s comes out to be equal to 0.6. When F is 15 Newton, this block starts sliding. So the friction will be now kinetic friction. So we can calculate its acceleration by this line. Applying the second equation of motion in a straight line, x is equal to x0 plus u0t plus half at square. x0 is initial displacement, that is 0. u0 is 0 because block was initially at rest. So x is equal to 1 by 2 at square, or a is equal to 2x upon t square. X is given as 10 meter and T is given as 5 seconds. So A comes out to be equal to 0.8 meter per second square. Kinetic friction will oppose the motion, so it will work in this direction. So resultant force will be F minus Fk. Fk is given by mu k n, where mu k is coefficient of kinetic friction, n is normal reaction, n is equal to mg. So Fk is equal to mu k mg. Now resultant force is F minus Fk, and that is equal to ma. So F minus mu k mg is equal to ma, or mu k mg is equal to F minus ma, or mu k is equal to F minus ma upon mg. We can put the values of F, m, a and g. F is equal to 15 Newton, m is equal to 2.5 kg, a we have found out as 0.8 meter per second square, g we can take 10 meter per second square. So mu k comes out to be 0.52. Second question, a body is in limiting equilibrium on a rough inclined plane at an angle of 30 degree with horizontal. Calculate acceleration with which the body will slide down when inclination of the plane changes to 45 degree. Take g is equal to 9.8 meter per second square. Suppose a block is kept on inclined plane. Angle of inclination is 30 degrees. This block is in limiting equilibrium. That means it is about to slide. Static friction force on it will work up the plane, opposing block's tendency to slide down. We will equate various forces working on this block along the plane and perpendicular to the plane. mg is its weight that works perpendicularly downwards at its geometrical center. Its component along the plane will be mg sin 30 and perpendicular to the plane will be mg cos 30. N1 is normal reaction by this surface on the block. So we will say Fs is equal to mg sin 30 and N1 is equal to mg cos 30. In case of limiting equilibrium, Fs is equal to Fsm, that is limiting friction. So Fsm is equal to mg sin 30 and N1 is equal to mg cos 30. We know the formula for limiting friction is equal to mu s into normal reaction. We will put values of Fsm and N1 from here to get mu s is equal to 1 by root 3. When angle of inclination of the plane changes to 45 degrees, this block will start accelerating downwards. That means net force on this block will be downwards. Component of weight of this block in this case will be along the plane will be mg sin 45 and perpendicular to the plane will be mg cos 45 and N2 will be mg cos 45. So net force downwards will be mg sin 45 minus Fs and that will be equal to ma. That will be equation of motion. Fs is equal to mu s into N2 and N2 is equal to mg cos 45. So we will put various values in this to get value of A as 2.93 meter per second square. Third question, length of a uniform chain is L and coefficient of static friction is mu between the chain and the tabletop. Calculate the maximum length of the chain which can hang from the table without sliding down. Suppose initially chain was completely on the table. You hold its one end and start dragging it down the table slowly. As the hanging part keeps increasing, its weight also keeps increasing. At a certain point of time, due to increasing weight, this chain starts sliding down on its own. We have to calculate that maximum length of the hanging part x. At that point, limiting friction of this chain will be equal to weight of the hanging part. Suppose mass of the chain is m, then mass per unit length will be equal to m by L. Limiting friction Fsm will be equal to mu into NAB and NAB will be equal to weight of part AB of the chain. So we will calculate weight of part AB of the chain and that will be equal to mass per unit length into length of part AB, that will be L minus X into G. So Mu into m by L into L minus x into G will be equal to weight of the hanging part of the chain, and that will be equal to mass per unit length into length of the hanging part into G. So x comes out to be equal to mu L upon 1 plus mu. In next video, we will see how to solve two-block system. If you have a question, you can ask me on my Discord server. If you have not subscribed my channel yet, please do so.